Hello, everybody, and good morning, and very welcome to the course Structured Property Relations. I am Mangia Murshid. Since 2012, I have been taking care of this course within the summer semester module of chemistry. And in this course, we learn how you correlate the atomic structure with its given physical properties. How the structure you can change when you change the chemistry, or vice versa, and its impact on the physical properties. So I am a chemist. I did my bachelor and master's in chemistry. During my PhD and several postdocs, I have been well trained to determine the crystal structure, to tune the crystal structure using X-ray diffraction technique, Newton diffraction techniques, with some complementary spectroscopic techniques. So let's have a look first what we learn within this course. So in this structural property relation course, we have basically two parts. So one is so-called the module MCM1, and the second part is MCM module 2. In the first lecture, in the first part, we have lecture part, which you will present from next week on. And then you have exam, term exam, and you have quiz. And in the part 2, so-called the seminar part, in the seminar part, you will be given some thermal expansion data. And out of that, you will calculate the thermal expansion coefficient of a given Bismuth-Bohr system. And you will finally model the thermal expansion using so-called the Gruneisen first order approximation. And this means that basically this MCM2 will be limited to thermal expansion protocol. And how the grading has been distributed between MCM1 and MCM2. So while in the MCM1, so it will take, the exam will take 50% and the quiz will take 50% of the marks. And in the thermal expansion protocol part, so in the protocol, we'll judge accordingly that you have writing. We would like to see your writing skill, scientific writing skill, that would give you 25%. Then your result, that would cover 50%. And then figures and tables associated with the protocol will take 25% of the mark. So this is how the marks has been distributed. And let's see what we learned in the lecture part. So in the lecture, basically all the course contents, the links of the references, the books, a small glossary relevant to this course, and you know that there is a blogging page that you can further discuss between you and me, and if any critical issues, if you would like to better understand some topic like this, the video of this course for every topic and the PowerPoint slides will be uploaded immediately after the lecture. So I will explain only, for example, what you will learn. You will learn crystal structure. What really does it mean, a crystal structure? the atomic ordering, the packing, and so on. And how to determine the crystal? Well, we will not determine exactly the crystal structure, but we will learn the technique, how the X-ray crystallography gives you the way that you understand, you intuitively understand that how the crystal structure has been identified. So we learn associated so-called the electrical properties, the magnetic properties, bond balance sum or bond balance theory. We learn stress, strain, elasticity. So these are basically some of the physical properties associated with your crystal chemistry. So let's give you an example that you may ask yourself, well, why manganese oxide is magnetic, but lead oxide not? Why chromium oxide is magnetic, while for instance, aluminum oxide not? So where is the source of these physical properties, and how you will tune these physical properties, changing the crystal structure or changing the chemistry within the crystal structure? So end of this course, you will feel like that, wow, well, this is the physical properties behind the strength of the wall, how the aluminum and silicon, so-called the alumosilicate bindings form within the alumosilicate crystal chemistry. And that gives you so stiff such building wall and the floors and the ceiling as well. So if at this point, if you have any specific questions, please. Unfortunately not. The question on whether we take care of also the organic crystallography or organic molecules or molecular crystallography. No, in this course not. But if you are further interested, so it is segregated and assigned to the other course, you can learn better there. So if you feel any questions and any type of complications, then you can discuss with me. And by the way, one important issue that during writing your protocol, you will be grouped 3-person, one group. You can choose your group mates, how to make your group, or I mean, if there are some students left, and then I can also help guide you how to do it. So if you don't have any further question, then we'll meet next week, the same venue, this hall room, and the same time. And I wish you a very good day.